Hello and welcome to today's video. Today we're going to be determining the minimum operations to return x to 0. So you're given an array nums and integer x, and in one operation you want to remove either the leftmost or the rightmost element from the array nums and subtract its value from x, and this modifies the array for future operations. We want to return the minimum number of operations to reduce x to exactly 0 if it's possible, otherwise we want to return -1. Now, we're given this example here where you're given a nums array and their output's going to be 2 because what you can do is really quickly grab the 2 and 3 here and have that be the minimum amount. Now, the other strategy, well, the other one would be if there's nothing possible, we want to return -1. Now, one potential way of doing this is to basically do a greedy solution where you take the best element at each step. And that's by effectively just initializing two different pointers and then like checking to see like what the best option is at each step. The problem with that though is if you grab 3, let's say like you have like 3 over here and you grab that because it's the most optimal, and then you grab 2, that's the most optimal, then of course you're going to return the right answer. But there's going to be all other situations as well in which you won't be able to grab the optimal one by just doing the greedy one at each step. So this is where you have to think outside the box a little bit. The reason why we can't do this is because not every single problem is perfectly lined up like this, where if you choose every single right option each step, it'll have the right answer. Let's see if, for example, number 3 over here, we have x is equal to 10. You want to remove the last 3 elements, this one, and the last 3 elements here and the first 2 elements in order to do total. So so we grab 3 here, we grab 1 here, 1 here, 3, 2, and then 2 here. Okay, one possible solution which I'm thinking of is that you can have a sliding window, and this sliding window can figure out what values are needed outside. You need to figure out the inverse of what numbers are needed. And what I mean by that is, if let's say you have these array values here, 1, 1, 4, 4, 2, 3. We create a window, let's say we'll have x equals 5, and we want everything inside the window to be equal to the length, to be equal to the inverse of what's needed. So let's say, for example, we know that we want it to equal exactly x, which in the situation is 5. Well, what do we need outside of it? We can figure out what that is by taking the sum of all the elements. So we have 4, 5, 6, 7, 8, 9, 10, 11, and subtracting 5 to know what's needed. And in this case, it's going to be equal to 6. So we know that if inside the window there's an element equal to 6, let's say here 4, 5, 6, right? Then everything that's outside of it is what you can use in order to grab it. So let's say we have 3 and then 4, 5. This is equal to 5, so we just need 3, 1, 1 in order to have it. And we know that we need exactly that amount, the minimum number of operations, for it to equal the value that we need. So, which is 5, right? So we can now that we know this, we can go ahead and begin implementing it now. What we can start off with is, first of all, figure out what that number is. So like what we need that number to be. So what we can do that is we can have like a target variable which is equal to the sum of every single number subtracted by x, because that's what we're trying to target. And from there on we can do a sliding window. So for r in range length of nums, what we can do is we can first have the condition to make sure that everything inside is going to be equal to the the number. So what we can do is we can have the sum of window, or actually we'll call it window sum. So what we want to make sure that window sum is always equal to 6. So what we can do is every single time that it's not equal to 6, we can go ahead and move the left pointer forward until it is. Well, if it's greater than 6. So while the window sum is greater than the target, right? That's the 6 in our example there. What we want to do is we want to move the left pointer forward. So we want to move the left and make it plus equal to 1. And then, as well as this, we want to do window sum minus equal the nums of the left one. Now, this will ensure that this always is equal to 6. Now, the next thing we want to do is we want to be obviously adding it to the window sum, right? So we do window sum plus equals nums r, and then for everything, it'll keep moving it on forward from there. At the very, while we're also doing this, we also want to keep track of what the actual result is going to be. So we'll set the result, and we want the minimum number. So an easy way of doing this, since we want the minimum number of operations of the inverse, so we want 113, we want to maximize what's inside here. So what you can do is you can have the max, we can create a max elements accumulator, or like a max elements variable, which keeps track, and we'll have that set to 0 initially. And then we want to set the max elements to equal the max of the left plus the right minus 1, because that's how you grab the elements within it. And then, as well as that, you also want to be grabbing the the current max elements to see which one's better. At the very end, what we can go ahead and do is, we also want to check for this edge case, where if it's impossible to do, you want to return -1. So, yeah, max elements. So actually, you want to return, you want to have max elements to be equal to -1 in this situation, and then otherwise, you want to return the length of the nums array, right, at the very end, subtracted by the values that are in there to grab the elements over there. So we want to grab minus the maximum number of elements, and we can have that to be our final value. So if you go ahead and quickly run this, well, actually, let's do one more check to see if we're missing anything. Yeah, okay, let's just quickly run this. Oh, oops, small typo. Oh, right. We also want to have we want to have start off with an L variable, which is a left variable, which is equal to 0, and then keep moving it on forward as we go. Forgot to initialize that at first. Okay. Okay, let's see here. For this one, we also want to make sure that at every point here, we want it to be equal to the target sum. So if the if the current sum or if the window sum is equal to the target, that's when you'll actually want to do this. Otherwise, you don't want to be adding it here. And then it should be good. If we run this again really quickly. Okay, so our output is 1, but we're expected to have 2. Now, why is that? This is the wrong formula. You need to figure out the elements within the sliding window. You have to do right minus the left plus 1. I always get that mixed up whenever I'm doing sliding window problems. Okay, now we're here. Our output is 6 when we're expected to have -1. Let's have a look why. maximum number of elements. Our output is 6 when we're expected to have 1. Oh, another thing we also want to do, check for, we want to check to see and make sure that left is always less than or equal to the right, otherwise it can move forward. But yeah. Yeah, that shouldn't be it, why? You're expected to have now -1. See if we're missing any edge cases here. You set the target equals sum of nums minus x, yeah. And you set window sum equals 0. You got the maximum number of elements. And then you have that set every single time if the window sum is equal to the target. And you want this to be the maximum of r minus l plus 1 and the maximum number of elements. At the very end, you want to return that, okay? 1, 2, 3, 4, 5. Oh, I see. We're returning, oh, this is the length of nums minus the maximum number of elements. But we don't, the maximum number of elements in this case because we never move the right one forward. Okay, let's think about this. While r is less than the length, okay, for r in range, length nums, we first move this forward. So the window sum plus equals nums r, and then while the window sum is greater and less than is equal to the right, you move the current sum, or and then you subtract it by that, add it by 1. Otherwise, you have to see if the window sum is equal to the target, which is that one, and then you set this to be the right minus the left plus 1, and then the maximum elements. And then you subtract the maximum elements at the very ends. Let's do like another quick check. If the max elements is equal to -1, well, we should just be returning -1. Oh, if it's equal to -1, then it might switch it the other way around. Yeah, because I just realized if you set the maximum elements at 1, that's not going to be the inverse actually. It's going to because I was thinking of just if maximum elements is -1, then I'll just turn -1. But I'm realizing that you're subtracting length nums with the max elements, so that's actually the reason why. If you go ahead and run this now, okay, great, it works successfully. And the time complexity of this operation is going to be O of n because you're iterating through at most all of the elements, just moving the pointers along forward. And the space complexity of this one should be O of n. Oh, no, should be O of 1 because you're not storing any of the stuff in place in the memory. So if we do a quick check, this is a new LeetCode feature, which is pretty cool. Yeah, O of 1. Okay. Well, thank you so much for watching.